Today, I'm going to talk about how to connect 3-phase pole lights with photocell and changeover switch. Let's start. We are going to make use of one photocell, two 4-pole breakers. One is going to serve as input breaker and the other one is going to serve as output breaker. One contactor, one changeover switch with 3-pole lights. And lastly, this thing that you're seeing, this diagram that you're seeing on your screen is changeover switch diagram to show the function of this changeover. In this connection, we are going to make use of 3-phase power supply: red phase, yellow phase, blue phase, and neutral. And we are going to supply all these phases to these input breakers. And the output of this breaker is going to serve L1, L2, L3, and normally open of this contactor. This or this. And the output of this contactor is going to come out from T1, T2, T3, and normally open to the output breaker. This contactor, we have different terminals and their work is different from each other. This L1, we have L1, L2, L3, and also T1, T2, T3. They are all terminals. This L1 linked to this T1, and same thing to these two L2 and T2, and then L3 to T3. And this normally open. If you check your contactor, they may not put normally open. You will see something like 13 and 14. 13 will be at the up and 14 will be at the down, and then 70 something, different kind of numbers. Different contactor comes with different kind of number. But what you really need to know is which terminals are normally open and which terminals are normally closed. This L1, L2, L3 with T1, T2, T3, and this normally open that used to come with 13 and 14, they are all normally open terminals. And this, the last one here, they are normally closed. It's normally closed rather, sorry. What did I mean by normally open and normally closed? Normally open means that these two terminals, this terminal and these terminals, they are not connected together until this contactor is energized. If this contactor is not energized, they are open, they are separate. Why this normally closed means that when this contactor has not been energized, this normally closed as closed together, and immediately this contactor energized, it will open. And here you can see another terminal here, A1 and A2. They are the terminal for the coil of this contactor. Without these two terminals, this contactor cannot energize. Anything you supply here will stay here. It can't be transferred to this side unless you connect it to normally close. But with this, your contactor can energize. And what we are going to do now is we are going to connect this A1 and A2. First, we are going to connect neutral to the A2. And also, this photocell has 3 terminals, 2 inputs and 1 output. Live and neutral for inputs, and then only 1 output will come out from this photocell that will supply, that will trigger or energize whatever we want it to energize. And what we are going to do now is we are going to connect neutral to the photocell. And before we go back to the photocell, I'm going to connect live to this changeover switch. You can choose any of these faces, but I'm using blue face here. And you know, this changeover switch has 3 sides. One is going to be manual, and the other one is going to be auto, and it will have another side as off, to off the whole system. You can see here auto, manual, and off position. Now we are going to connect the auto side of this changeover switch to the photocell. And output of this photocell is going to connect to this A1. That means automatically, if we change this to this side, since we have the both live and neutral as input for the photocell, in the dark place, the photocell will supply and energize this contactor. Okay, and then we are going to connect the manual side of this changeover switch, and it's going to come out from here, and it will also serve this A1 too. After that, we are going to go back to this output breakers and use it to supply the 3-pole light. First, we are going to connect neutral to all the pole lights. We are using 3-phase power supply, and we are using 3-pole lights. What we are going to do is we are going to do load sharing, and for us to do it, we are going to use 1 phase for 1 pole light, for each pole light. That means, what I'm saying is, blue phase is going to serve the first pole light, yellow phase is going to serve the second pole light, and red phase is going to serve the third pole light. And in a case where you have like many pole lights, like let me use 12 as an example. Divide 12 by 3, and then you are going to use, that means you are going to use 1 phase for 3 pole lights. And it will be very okay if you can split it, like the way I want to do it here. You use blue phase to serve the first pole light, and then yellow phase to serve the second, red phase to serve the third, and continue it like that. Why all this thing is necessary is, first thing, you are going to do your load sharing. There will be no more load on one phase, and the other phase will have lesser load. And then second thing, in case if any of these phase has issue, maybe go off, you won't have one side of the street lights like that, because you split the phases. The first one, maybe the yellow phase is off, definitely you will have the first street light on, the middle is not going to on, and the third one is going to be on. All these things will not allow one side to be dark and the other side there will be light, if you can split it like this. Hope you understand what I'm trying to say. But let's continue with our connection. We're going to use blue phase for the first pole light, this one for the second pole light, and red phase for the third pole light. Now we are through with our connection. We are using manual here. You can see that this switch has been turned to manual side, and this is what is going to happen. The way current will flow from here, from supply here to the pole lights. Let's say how the current will flow. There is the current flowing from input breaker and then to the contactor. Now this thing has stopped. You can see that this neutral serve this, and then all these 4 terminals has been served, but there is no output of it because this contactor has not been energized. And what will make this contactor to be energized is this switch, changeover switch, must supply to this A1. so that the contactor will energize and the output will come out. And that's what is going to happen. Immediately the output come out, and the output from output breaker straight to the pole light, and the lights will come up immediately. And now let's use auto. Let's see how the auto will look like, and you can see the diagram. Also, we are on automatic side now. You can see that this switch has been turned to the automatic side, and you can see the diagram also. So let's see how the current will supply from the source to the input breaker and others. Now current will flow, input breaker, and then the output of this input breaker goes straight to the contactor. And you can see that this current stop here on the contactor, because this contactor has not been energized. And what will energize this contactor is the current from this photocell, and how this photocell is going to give supply to the contactor. And let's see how all these things will play out. First, the supply will go from the changeover switch to the photocell. Now the photocell has received both live and neutral, and then it remains one process for this photocell to give out the output. Immediately the surroundings of this photocell is dark enough, it will give out output, and you can see that the output has been supplied to the A1, and then contactor will energize and release output out to the output breaker, and output breaker straight to the pole lights.